examples of the sine and cosine functions so that we can understand those a little bit better. I'm going to be drawing them and erasing them through each change that I make through the function. But if it helps you to graph them on multiple graphs so you have each step, then you should go ahead and have graph paper or something ready that has those multiple graphs for you. So this is our horizontal changes, and these are our vertical changes. Okay? So like we talked about in class, the first thing we're going to adjust is the period. And normally the period of the sine function is 2 pi. But because of that pi over 6, I'm going to multiply it by this 6 over pi, which is a horizontal stretch. And the result is going to be 12. This means that the period of this function is 12. Now, that means because the horizontal stretch was in terms of pi, it doesn't look like a radian like you're used to seeing as like pi over 3, pi over 4, pi over 6. It still is. It's just 12. So that means I'm going to make the fourth mark on my graph equal to 12 if I want to use the same pattern of points as normal. Okay? So normally the sine function goes through this pattern of points. So this is the parent function, but it's been adjusted to a graph so that one cycle or period of the function takes 12 units instead of 2 pi. Now that means that this first mark here is going to be 3 because I'm just going to divide it by 4. So it's 3, 6, 9. On this side, negative 3, negative 6, negative 9, negative 12. Okay? And these are still measured in units of 1. So then the other transformations here are I need to shift everything up 1, and I need to change the amplitude to 2. So by shifting everything up 1, these points that are along the midline of the graph that are normally on the axis, they're now going to be up at 1. And remember, there's a point between them that was above them. It's going to be above them, but rather than 1 unit above the midline, it's going to be 2 units above. And this point that was below is still going to be below as a minimum, but 2 units below the midline at 1. So it'll reach down here. Okay, so this function looks like this, and I can extend to more periods of the function by following the same pattern of points in either direction on my graph that I have space to do so. So there's a graph of this function. Okay? So the period, we calculate it as 12. The amplitude of this graph is 2. Okay? The domain is all real numbers. The range, notice that my points bounce from negative 1 to positive 3. So negative 1 is less than or equal to y is less than or equal to 3. Okay? And the zeros of the graph, I would have to actually set it equal to 0 and solve. We're going to get more into that in the next unit. Okay? So let's look at another. So here, this is all horizontal stuff here. Okay? This is the number that's going to stretch or compress horizontally and change the period. So with that being a 3, the period for my graph, again, is normally 2 pi, but it's getting compressed by a factor of 1/3. So the period of my graph is 2 pi over 3. So again, to use the same sequence of points as normal, I'm going to just renumber my graph to show the stretch or compression. I'm going to divide 2 pi over 3 by 4. So if you have to, do the arithmetic off on the side. Dividing by 4 is the same as multiplying by 1/4. So pi over 6 is what each tick mark on my graph represents. So then this would be 2 pi over 6, which reduces to pi over 3, 3 pi over 6, which reduces to pi over 2, and then 4 pi over 6, and then the negative values on this side. And so again, my sine function cycles through the values. Again, this is the parent function just adjusted to a new period. Okay? I've stretched and compressed the graph by changing the scaling. So I've taken care of that 3, but I have 2 other changes to make. I need to move my graph to the left pi over 6 And then I need to take care of this reflection and compression. So the first thing I'm going to do is move it to the left pi over 6. On my graph, that is 1 tick mark. So this would be moving to the graph left pi over 6. Okay, so that's taken care of. And then last but not least, I have this reflection and compression. So it's a vertical reflection. So points that are on the midline are not going to move because they're not going to get reflected or compressed. But like this point here was a maximum, so it was 1 unit away. With this 1/2 in front of the function, we're going to make it only half a unit away. And because the negative, rather than being above the midline, it's going to reflect and be below the midline half a unit. Okay? Same idea for this minimum here. Okay? The 1/2 is going to make it so that it's only half a unit away from the middle. The reflection is going to make it so that it is above rather than below. So the end result here is this blue graph that I'm drawing. And like I said, we can extend it in each direction following this cycle or pattern of points. Okay. So the period for this function we already calculated is 2 pi over 3. The amplitude here is half a unit. Again, the domain is all real numbers. And the range here is that the function's y values are between -1/2 and +1/2. And let's remember our interval notation because you guys will be using this when you move on to pre-calc and calc. Okay. All right, we're going to do one more example for you guys. Except I did this as a sine function.